Exploring innovation space. In this module, we're looking at the different ways in which we can innovate. And in this particular film, we're going to focus on the concept of component and system level innovation. We've already seen that innovation can take place across a spectrum of novelty, from incremental change, doing what we do but better, right through to radical change, doing something different. And we can position our innovation anywhere along that spectrum. And we've also explored the idea of directions for innovation. Particularly, we looked at the innovation compass and saw that we could innovate in at least 4 directions and indeed in the space between them. But what we want to focus on here is the idea of different levels of innovation. Now, if you think about it, innovation can be a bit like those Russian dolls. You know, one doll fits inside the next, and so on. Now, if we think about it, innovation can happen in that way. We might make a small change at the bottom, which hardly affects the full scale, or vice versa, we might change the very top level, and that has implications right through the piece. Think about that in the concept of a motor car. Now we look at a car, and of course that is like the big mama in terms of the Russian dolls, the great big top-level innovation. That's a system. But if we were to break that down, there are various elements of that system. For example, we've got the wheels, 4 of them, and within those wheels, of course, we've got all sorts of things going on. For example, a very complex arrangement of pipes and cantilevers and brakes and pads, the disc braking system. Or take another part of the car. Think about the fuel system. From the inside, we can just see from the gauge whether we've got fuel or not. But if we break down the system that's managing all of that, it's got a lot of different components. All sorts of pipes, tanks, levers, pumps, etc. So there's innovation possible at all of these levels. From the very top level system, changing the whole car, right through to each individual component. For example, replacing a metal pipe with a plastic one in the fuel system. Now, changing these at different levels has different implications. If we were to change the material in that pipe for the petrol system, it's not going to make a big difference. Certainly at the level of the whole system, it hardly changes things. But if we were to switch from petrol to electric power, that has some very big implications. Basically, we wouldn't need much of that old-fashioned fuel system. We'd need to look for a new way of delivering the power and managing and harnessing the energy based on batteries. So, at the extreme, if we carry that forward, we might change the entire top-level system. Our car takes out the driver, becomes like this futuristic picture, a driverless car, and then there are big chunks of the car we currently think about we no longer need. What's the point of all those dials and instruments or a steering wheel when it's a driverless car? So the point really is to think about innovation at these different levels. From the system level, where everything changes, right through to the component level, which sits within a system, where we can make changes without necessarily challenging the whole. Now we can think about this in terms of a simple model. And this diagram here basically shows how we could begin to conceptualize the challenges at different levels of innovation. On the bottom, the horizontal axis, we've got our familiar spectrum, doing what we do better, incremental innovation, right the way through to radical, perhaps new to the world innovation. But now on the vertical level, we think about the different component to system levels we might operate at. So in those bottom 3 areas, those bottom 3 cells, we have incremental change in components, perhaps changing the components in an existing system, replacing them with something else, or perhaps doing something fairly radical with those components. But change is easy to manage, or relatively easy to manage in those spaces, compared to when we move to the system level, where we might be talking about new generations of the motor car, or the aeroplane, or the television set, right through to completely new revolutions in terms of the way we do things. And the important point about this picture is simple. If we're going to manage innovation in the bottom left-hand corner, it's fairly straightforward, just as incremental innovation is fairly simple. By the time we get to the top right-hand corner, system level change of a radical nature, we have some really big issues to think about. This brings us on to a really important current topic, the idea of platform innovation. Now, the idea of a platform is essentially a system-level innovation where all sorts of different applications can be configured across the same basic platform. Rather than combined in a system like a motor car, this is essentially bundling up knowledge into a particular format and deploying a variety of innovations linked to that family. A few examples might make that clearer. Think about Lego bricks. They've been around for 70 years or so, and essentially it's the same basic point. These are different sized bricks that fit together in all sorts of wonderful ways, but essentially there's an underlying architecture, a platform on which that knowledge is used and reused and deployed in all sorts of ways. It's not a new idea. Massey Ferguson, the famous tractor manufacturers, the Ferguson part comes from something called the Ferguson System. And in the early days of tractors, Massey Ferguson used the Ferguson system to basically link the power of the tractor to all sorts of implements that you could fit on the back of the tractor. So there would be ploughs and pumps and drills and all sorts of things a farmer might need. Essentially, all these different innovations would fit together around the Ferguson system, a platform innovation. We may not see much of them, but in the many computers and other devices powered by Intel, this idea of Intel inside, what we really have is a platform, an architecture, all sorts of microprocessor instructions and software linked to the hardware that drive entire systems for managing the various tasks a computer has to do. And if you look at our smartphones, they're wonderful devices for communicating, but their real power is that they offer a platform across which we can place all sorts of apps for our very many different needs. So, platform innovation is a very important concept, and it has strong links to this idea of system-level thinking. Particularly, platform innovation reuses knowledge across many different applications. It creates a system level within which we can continue to add component modules linked into the core architecture. And that, of course, means we can extend the life of our core product and broaden the market. There's a concept sometimes used called robust design. The Boeing 737 is a good example of robust design. A plane that's 70 years old, but basically still running and still being offered in new variants built across that core platform. But there is a downside to platform innovation. What happens when the game changes? And basically what goes on here is that new architectures, new ways of putting things together in systems not only require new knowledge, they also require new linkages between those knowledge elements. So there are big advantages to platform innovation. The risk, of course, is if we build everything on a platform, when the game changes, we may be in trouble. So, a brief summary. Innovation can take place at component or system level, as well as in different directions and as well as with different degrees of novelty. Changes at the component level don't disrupt the system level, so we can make those small changes without necessarily having to change the core system. But at the other way round, changes at the system level may challenge our components and even make them redundant. Think about shifting from a fuel based on petrol to a fuel based on electricity in a motor car, and how much the car component innovations would have to change. Platform innovation involves building at a system level an architecture and then developing a range of modules to work within it. This offers what we call economies of knowledge use. We can increase the scale, extend the market, and the scope. We can broaden out the areas of application. But the risk comes when the whole architecture changes and we need new knowledge and new relationships between that knowledge.